to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, wonderful students of Senior 1. I'm your chemistry teacher once again, and I hope you are there. I just want to welcome you. This time we are just going to look at unit number 12, inorganic salts and their properties, and we are on lesson number 1. We'll just be looking at the nomenclature, formation, and solubility rules of the salts. So in the nomenclature, that is the system of naming these compounds and how these salts are formed. And remember, we are only emphasizing the inorganic salts because there are other salts which are also organic, and we are not going to look at those ones. We'll only be looking at inorganic salt. So here I have some questions that I will be asking you. And the first question is, what is the importance of table salt? We know we all take salt at home, and we always have salt that is put into the food. What is its importance? Is it the taste? Are there some other uses? So you need to know that. Did you know that many other substances also contain salt? I'm sure maybe you didn't know, but there are some other substances that contain salt. For example, you have ever seen animal feeds. You have seen maybe animal feeds such as rabbit pellets, the calf flakes, and chicken mashes. You have seen some of the fertilizers that we were mentioning in the previous lesson, that these are some of the examples of the salts. But do you know that they contain various types of salts? These salts vary from one compound to another. So we'll just look at some of the pictures, A, B, C, D. We have A, B, C. You have, this is maybe this could be fertilizers. This is chicken mash. I can see there is layers mash. And I can see this is rabbit, like rabbit pellets indicated there. Those are some. These substances contain salts. These are some of the examples that contain salt. So just what do we understand by the term salt? If we say salt, is it the salt that we eat? No, it is not the salt. Yes, the salt we eat is also, don't say that the term salt means the salt we eat. No. There is a chemical terminology for the salt. So in chemistry, when we are talking about salt, we are not referring only to that salt that we eat, because there are a number of salts apart from the table salt, which is sodium chloride. So name any 5 salts that you know. Are there some other salts that you know? We have mentioned some salts even before in the previous lesson. We talked about the sulfates. So this could be either ammonium sulfate. You could talk about the ammonium chloride and so many others. So it is very important also to mention. You can mention as many as possible. You can also talk about sodium carbonate. These are many other examples of salts. You can talk about sodium hydrogen carbonate. This is the baking powder, or it is the baking powder, or sodium bicarbonate. That is how it is normally called, sodium bicarbonate or sodium hydrogen carbonate. So these are some of the examples, and there are very many of them. There are a number of them. Salts, how are these salts formed? Salts are named depending on the acid they are derived from. So when we are naming these salts, we need to know the acid from which they are being formed. For example, if I say sodium sulfate, so we have sodium and then we have the sulfate. So it is very important to note that this sodium sulfate is formed from the acid that contains the sulfate. That radical, this sulfate radical, is coming from the acid. So they are named from the acids they are being derived from. So sodium sulfate, that means the acid here that is derived, where the acid is derived, this salt is derived from, is this sulfuric acid. So that is why we have sodium sulfate. But we can also have sodium nitrate. This is sodium nitrate. So when we say sodium nitrate, this is made up of sodium, metal, and the nitrate. So where is the nitrate coming from? This nitrate is coming from the nitric acid. So you should also note that. If we say ammonium chloride, that is one other example, ammonium chloride. If we have ammonium chloride is derived from hydrochloric acid, because the acid is the one that is providing this radical, the chloride ion. So it is very important to note that. For example, I have a table on the screen. When you go to the screen, you see the table, there is hydrochloric, we have the acid, we have the base, and then we have the name of the salt that is formed. We have hydrochloric acid and sodium hydroxide. So that takes us back even again to the reactions that we are looking at. So if we have, the first one is hydrochloric acid. So we have hydrochloric acid plus sodium hydroxide. So this one will give us sodium chloride and water. But the sodium chloride is the salt. So the salt, that means the sodium, we are having this sodium combining with this. And therefore we are forming this. When you look at this, the sodium displaces this hydrogen ion, and then it becomes, the salt is formed. We have sulfuric acid, which is combining with the potassium hydroxide. So this one will form potassium sulfate plus water. But I'm not interested in the water, I'm interested in this salt. This is potassium sulfate. It is derived, now you see, these hydrogen ions have been replaced by 2. So this is why we need the 2 here. So it has been replaced by 2, the 2 hydrogen ions replaced by 2 by sodium, by potassium metal. 2 atoms, so that is potassium sulfate. We have nitric acid, when you look at the screen and on the last number, which is combining with magnesium hydroxide. So which salt do you expect to get there? Can you suggest the salt that you are getting? When you have nitric acid and magnesium hydroxide. So what we are getting here, we are seeing that the hydrogen is replaced by the magnesium. And therefore, we are having magnesium nitrate. So this will be the salt that will be formed. Magnesium nitrate, then plus water. So it is very important to note that acids, salts are derived from the salts, and it is where the salts are also named. They are named depending on where they are coming from. So can we write the formula of such a salts? Those are some of the examples of the salt. I said salts, there are a number of them. So can we together write the formula of the salts? I hope you are writing down already, you have finished. So we have potassium nitrate. So if we have potassium nitrate, this is how we write potassium nitrate. This is potassium nitrate. Potassium nitrate. We have sodium chloride. This is the formula for sodium chloride, the table salt, which is what I hope everybody know. This is sodium chloride. Sodium chloride. So we have as well, we are having calcium sulfate, so it will be calcium and then sulfate. That is what you should know. And then we have zinc chloride, zinc chloride. We had looked at this before. So because this is writing the formula of the compounds, and these are some of the compounds that we had even written before. So you should be able to remember that these are also the salts. Now, what do we mean by the salt? As we have mentioned earlier, a salt is formed, or is that compound that is formed when a hydrogen atom, this hydrogen here, is repressed by a metal. When the hydrogen ion of the acid is repressed by the metal or ammonium ion, then that is what we call the salt. So it is a substance formed when a hydrogen atom in the acid is repressed by a metal or ammonium ion. That is what we mean by the acid, by the salt. So for example, we have said, if you look at this potassium sulfate, this potassium sulfate is formed from sulfuric acid. And we have said, now if you have potassium sulfate, you'll see that the potassium ion, these potassium metal atoms are repressing the hydrogen ions. And if these potassium repress the hydrogen atoms, then what is formed is called a salt. Or we can say, we have said even ammonium ion. So we can have ammonium chloride. This ammonium chloride, as we have mentioned, it will be formed from hydrochloric acid. So it has either the hydrogen ions being repressed by ammonium ions. So that is the salt that will be formed. So it is very important. However, we have two main types of the salts. Two main types of the salts. One is the normal salt, and another one is, do we have the abnormal salts? If we have the normal salts, which other salt that we have? Normal salts, and then we have what we call acid salts. We don't have abnormal salts because they are normal salts. What we have is the normal salt, and then another one is the acid salt. So what is the difference between these two when we are talking about the normal salt? For example, if we have sodium nitrate, this is an example of the salt. This sodium nitrate or sodium chloride, this one is formed from nitric acid. This one is formed from hydrochloric acid. And what is happening? When you look at this sodium nitrate, the sodium metal have completely repressed the hydrogen ions. The sodium here in sodium chloride completely represses the hydrogen from the hydrochloric acid. So when we have these salts, now look at this example, hydrogen sulfate, sodium hydrogen sulfate. When you look at this acid salt, this one is formed from sulfuric acid, for example. Now, see the difference between the normal salts and acid salt. In the normal salt, the hydrogens in the acid are not completely repressed. We have one hydrogen remaining there. So it is very important to see this, that it is very necessary. We said there are two salts, the normal salts and the acid salts. And what is the difference? The difference is on the repressment of the hydrogen atoms. Here, in the acid salt, one hydrogen, or there is partial repressment. Some of the hydrogens remain in the salt. So because of this, the presence of the hydrogen in the salt, that is why it is called the acid salt. This is the normal salt where all the hydrogen atoms, where the hydrogen atoms in the acid have been completely repressed. So it is very important to note that one. Now let me just give you an example. If we have this copper sulfate, we have copper chloride, we have calcium hydrogen carbonate. Can you identify among these ones? These are all salts. Among these salts, we have normal and acid salts. So how do we identify the acid salts? How do we distinguish the acid salt from the normal salt? This is how we distinguish. The moment we identify that there is a hydrogen atom, it means that there was partial replacement of hydrogens from the acid. These are normal salts. So this is normal salt, this is normal salt, and this is acid salt, because it contains some hydrogen atoms that remained in the salt during the formation. So it is very, very important. So the number, when we look at the acids, for example, something also we need to mention here, we have a number of acids as we have looked at them before. We have this acid. What is the name of this acid? I hope you still remember. This is sulfuric acid. We have nitric acid, and we have hydrochloric acid. These are common acids that we can find in any simple laboratory. Now, when you look at these, this one has 2 hydrogen atoms. This one has 1 hydrogen atom. This one has 1 hydrogen atom. But if you look at this has 3 hydrogen atoms. And what is the meaning of this? So we use the word basicity to describe the nature of these acids. So those ones that have 1 hydrogen atoms, they are said to be monoacidic, or we say monobasic. Monobasic acids. They have 1 hydrogen atoms. Those are monobasic acids. Those that have 2 are called dibasic acids. So we use the prefix di, dibasic acid. If they are 3, then we use tribasic acids. Tribasic acids. So if there are many hydrogen, the hydrogen atoms, they can be polybasic acids, or it can be a polybasic, but poly refers to many. So this is the difference on the acids that you need to remember. The number of hydrogen atoms are used to describe the nature of the acids. The number of hydrogen atoms contained that can be repressed, by the metal to form the salt. This is how we describe the acids: monobasic, dibasic, tribasic, and polybasic, depending on the number of hydrogen atoms present in the acid. Now just go to the screen over there. You look at some of the reactions. Now those 2 reactions are forming 2 different acids, the 2 different main salts. So we have the zinc sulfate reacting to form zinc metal on the screen over there. So we have the zinc metal reacting with sulfuric acid. It is forming a normal salt, which is zinc sulfate, and the hydrogen gas. But what is important is not the hydrogen gas that is formed, but it is the salt that is formed. When you look at the salt, because here we have 2 hydrogen atoms. And when you look at the salt, it means that the 2 hydrogen atoms have been completely replaced by the zinc. And when you come down, so this one becomes the normal salt. When you come down to the reaction below, we are having sulfuric acid combining with sodium hydroxide. So we are having the sodium hydrogen sulfate. There is a hydrogen atom that has remained there. And what is the meaning of that? It means that that salt is acid salt. Normal salts, acid salts. What is the difference? The difference is on the number of hydrogen atoms that can be replaced by the metal or the ammonium atoms, ions. If the hydrogen atoms are completely replaced, then we have a normal salt. If part of the hydrogen atoms are replaced, then we have an acid salt. So acid salts are characterized by having the hydrogen atoms in them. That is very important. So sodium hydrogen sulfate, salt, has 1 hydrogen atom, and therefore that is why it is regarded as an acid salt. If there is no any other acid, if there is no other any hydrogen present, then it will be a normal salt. So here I have a number of examples. On the screen, there's a number of examples. And on the table, we are having the acid and its formula. The acid and its formula. So we have the acid in the first column and its formula. We have the class of the salt. We have the type of the salt. And then we have some examples. So here we have what we call chlorides. That is the class of the salts. Then we have nitrates. We have sulfates. We have hydrogen sulfates. We have carbonates. And then we have hydrogen carbonates. These are different classes. So under different classes, we can have either normal salt and also we can have acid salt. So when we have these, the hydrogen sulfates, that means those ones will be acid because they contain the acid in them. The hydrogen carbonates are also acid salt because they also contain the acid in them. That's why we have calcium hydrogen carbonate. This is an acid salt, and this is formed from the carbonic acid. So these are normal salt. Sodium hydrogen sulfate, it has the hydrogen in it. But the rest of these sulfates we look at here in the table, all those are normal because there is no hydrogen. Sodium chloride, calcium chloride, potassium nitrate, lead to nitrate, magnesium sulfate, lithium sulfate, all those are normal salts. So what are these, the physical properties of some of these salts? We just want to mention some of the physical properties among the soluble salt. So among the salts that we have the solubility. Some are soluble and others, they dissolve in water. That's what I mean. They dissolve in water, and some dissolve depending on the conditions that are applied, either when they are heated or when they are cold. So, but the physical property that we are talking about here is the solubility. So there is the solubility. Some dissolve in water, others dissolve, others do not dissolve, and others dissolve at certain conditions of temperature, either when they are heated. Now, these are the solubility rules that we need to remember. This is very important because as we look at the salts, we need to remember the solubility rules. That all the nitrates, you remember nitrates is a class of the salts. All nitrates are soluble. Or sodium, potassium, and ammonium salt. Any salt of the sodium, potassium, and ammonium is soluble in water. All carbonates, salts, are insoluble in water. All carbonate salts are insoluble in water, except sodium carbonate. Sodium carbonate, just go to the screen and look at those carbonates that are insoluble. Sodium carbonate, potassium carbonate, ammonium carbonate. This ammonium carbonate is soluble in water. All sulfate salts are soluble, except this lead sulfate is insoluble, barium sulfate is insoluble, calcium sulfate is insoluble, but slightly, when we say sparingly soluble, so there is some degree of solubility in water, but very small. All chloride salts are soluble. All chloride salts are soluble, except lead chloride, that is the salt of the chloride that is insoluble, lead chloride, silver chloride, and lead 2 chloride is soluble in hot water. Lead 2 chloride is soluble in hot water. Silver chloride is insoluble. Lead 2 chloride is, rather silver chloride, lead 2 chloride. So those are the 2 chloride which are insoluble. But lead 2 chloride, when it is put in water, it dissolves. All sulfates are soluble. So we are mentioning the 3, lead sulfate, barium sulfate, and calcium sulfate. Those are the ones which are insoluble. All nitrates are soluble. All sodium, potassium, and ammonium salts are soluble. Dear students, this is what we are supposed to discuss. We looked at the nomenclature of the salts, how the salts are formed. We said they are formed from acids and named. That is how they are named. And then we mentioned the types of the salts, where we said there are 2 main types, and we said the normal acids, normal salts and acid salts, where we said the normal salts doesn't contain the hydrogen atoms, whereas the acid salts contain the hydrogen atoms. I hope you've been together and we've been following the lesson, and you've been able to capture everything. We talked about the basicity. That's what I can also remind you. The number of hydrogen atoms that can also be replaced by the metal to form the salt. Dear students, thank you so much for being there with me along all these 30 minutes. I hope to see you in the next lesson. Bye-bye.